Okay, so we're going to start our video or our unit on slope right now. So this video is going to be about the 4 different ways we can find slope. Your objective is that you're going to be able to find slope from a graph, an equation, a table, or 2 points. And we're going to start off with the 2 points. So just to start off, slope measures the steepness of a line. So this is really going to help us when we're graphing lines. So you can have a positive slope, which right here it shows it's like going uphill. It's rising from left to right. A negative slope is like going downhill. It's decreasing from left to right. Your slope can be 0. That happens when you have a horizontal line. And your slope can be undefined, which is only when we have a vertical line. So the equation that we're going to use to find slope from 2 points is m, which is slope, equals y2 minus y1 over x2 minus x1. So when we're given 2 points, we know that they're written as x comma y. So we're just going to pick one to be x1, or like this is set 1, this is set 2. So that means this is x1, y1, x2, and y2. So again, our equation is m equals y2 minus y1 over x2 minus x1. So now when we are plugging these in, we have m equals y2 minus y1 over x2 minus x1. And then we just simplify this and solve, so we're going to subtract on the top and bottom, and then see if we can divide. So 10 minus 5 gives us 5. Negative 2 minus 3 is negative 5. 5 divided by negative 5 is negative 1. So our slope here is negative 1. Looking at this second example, we have negative 2, 6 and 2, negative 6. So we want to find the slope of the line that connects these 2 points. So negative 2 is x1, 6 is y1, 2 is x2, and negative 6 is y2. We're going to plug them into the same equation. So m equals y2 is negative 6 minus y1 is positive 6 over x2 is 2 minus x1 is negative 2. Now, whenever you have a double negative here, so this is probably going to happen a lot in slope, it becomes a plus. So we really have negative 6 minus 6 over 2 plus 2. This is because this negative 1 would technically be distributed in, so it becomes a positive 2, so it just becomes 2 plus 2. Now, negative 6 minus 6 is negative 12, and 2 plus 2 is 4. So our slope here is negative 12 divided by 4, which is negative 3. Now, sometimes you're going to get slopes that don't divide evenly, so we could end up with like 5 over 7. You're going to leave it like that. You're not going to divide it or anything. Your slope would just be 5 over 7. So now we're going to get slope from a graph. So you're going to find 2 points that go exactly through like a point, like right through there or something. You don't want ones that go through unevenly, like we wouldn't pick right there or right here because they're not exactly on a point. So in this first example, we have 2 that are already highlighted for us. You're going to count the rise over the run. So you're going to take the point to the left. I should pick a color that's not red. We're going to pick the point to the left and see if we have to go up or down to get to the next point. We're going to go down 1, 2. So we're going to write negative 2 since we went down 2. Then we're going to the right 1, 2, 3, 4, 5 to get to this point. So we write positive 5. So on the top is your change in y, and on the bottom is your change in x. So you're counting how far you have to go up or down first, and that goes up top. And then you're counting how far you have to go left or right second, and that goes on the bottom. And then just like when we were graphing points, up gives us a positive sign, down is negative, left is negative, and right is a positive sign. So our slope here is negative 2 over 5. For this next one, it doesn't have highlighted points for us, so we can pick any 2. So I'm going to pick that one right there, this one right here. I'm going up 1, to get to that next point. So we're going to do 1 over something. And then we're going over 1 to get to that point. So our slope is 1 over 1, or just 1. So you just count how far it takes you to get up to the next point, and then how far it takes you to get over to the next point. Now we're going to find slope from a table. So just like when we were making our tables from like 2 units ago, all of these are just ordered pairs. So we have 2, -5, 5, -1, 8, 3, and 11, 7. So now we can just pick any 2 of these points we want and do what we did in that like first slide, the m equals y2 minus y1 over x2 minus x1. I always think it's hard to work with negatives, so I'm going to pick the 2 positive points. So I'm going to do 8, 3, and 11, 7. So we have x1, y1, x2, y2. We're just going to plug it in. M equals y2 minus y1 over x2 minus x1. 7 minus 3 gives us 4. 11 minus 8 gives us 3. This can't be divided or simplified, so our slope is just 4 over 3 in this case. It is allowed to be fractions like this. Lastly, we're going to find slope from an equation. So this one might be the hardest one. We're going to try to get y by itself or solve for y, so that our y will be by itself on the left, and our equation looks like y equals mx plus b, which is actually slope-intercept form, which is what we're going to be doing next. And your slope would be m. But so you're going to add or subtract any x term to the other side first, then divide by whatever coefficient is in front of the y. And then whatever number is connected to your x, that's your slope. So in this case, we have to subtract 3x to the other side. Since it's positive, you do the opposite sign. We get y equals negative 3x minus 9. Nothing's connected to that y, so this just is our slope. Our slope is negative 3. It's whatever's connected to that x. Over here, same thing, move your x term over first. It's positive, so we're going to subtract it. So now we have 3y equals negative 2x plus 9. And then you divide everything by whatever's connected to your y. So we get y equals negative 2 over 3. If you divide it and it's a fraction, just leave it as that fraction, plus 3. So our slope in this case would be the number connected to that x, which is negative 2 over 3. So m is negative 2 over 3. So we're going to practice all 4 of these methods tomorrow in class, so come to class with any questions you have.